Okay, let's get started. So before we start with the new work tomorrow, I just want to go over some revision of what we've done so far. So that is all of the derivative rules, the implicit differentiation, and the derivative of inverse functions. Okay, so we're going to need to know all of that for the new work coming up. So I've got here 32 questions for revision. Anything we don't cover today, I'll leave that for homework. Okay, and then you can spend the holiday going through the rest of them. Okay, then tomorrow we're going to start on L'Hopital's rule. So the notes are already up, so you can have a look at that. And then the tutorial for that will only be after we get back. Okay, so there's the tutorial 6 that you can do during the holiday. And then the L'Hopital's rule tutorial, that will be after that. Okay, so let's get started. So number 1, we have y is equal to tan inverse root x. Okay, and we want to find the derivative. So first of all, notice that this is a composition of two functions. We've got tan inverse on the outside, we've got root x on the inside. Whenever you have a composition, you need to think of the chain rule. Okay, composition, chain rule. Okay, we've got the inverse tangent, so that's one of those ones that we covered yesterday. So the derivative of that is going to be 1 over 1 plus x squared. Okay, that should already be in your books in that table I asked you to draw. So it's going to be 1 over 1 plus the stuff inside squared. So root x squared. So we'll start with that. So it's going to be 1 over 1 plus the stuff inside squared. Okay, so that's the first bit. That's differentiating the outside function. Now differentiating the inside function, that's the derivative of root x. You can think of that as x to the half. Then we use the power rule, and we end up with 1 over 2 root x. Okay, you can leave it like this. That's perfectly fine. If you want to put the root x squared as x, that's fine as well. It depends on what kind of question you get in the test. If there's follow-up questions that require this, maybe simplifying would be better. But if it's just a question on its own, there's no real need to simplify. Okay, number 2, we have y is equal to the natural log of x squared plus x. Okay, again, we've got a composition. The natural log, that's the outside function. X squared plus x, that's the inside function. So we're going to have to use the chain rule. We ignore the inside part and we just look at log. The derivative of the natural log is 1 over the stuff inside. So it's going to be 1 over x squared plus x. That takes care of the outside function. Now we need to multiply by the derivative of the inside function. So the derivative of x squared plus x, that's going to be 2x plus 1. Okay, and you can write this together as a fraction if you want. So that's 2x plus 1 over x squared plus x. Okay, again, whenever there's a composition, you need to look at what the outside function is, how does that behave, and the inside function, how does that behave. Okay, number 3. We have y is equal to x squared e to the x. Okay, so here we don't have any compositions, but we do have a product. We've got one function x squared and another function e to the x, and they're being multiplied. So we need to use the product rule. So we differentiate the first one and leave the second alone. So the derivative of x squared, that will be 2x, and the other one we leave alone. Plus. Now we leave the first one alone and differentiate the second. So that's going to be x squared for the first one. The derivative of the second, that's just e to the x. Okay, we went through why that's the case. Okay, no need to simplify, no need to factor. You can leave it like this, that's perfectly fine. Okay, if you want to simplify, you can, but if you get your final answer wrong, then that's a problem. Okay, if you leave it like this and it's correct, you get all the marks. Okay, I'm not marking simplification. I'm marking, can you do the derivative? Okay, number 4. Okay, so here we have y is equal to sine inverse natural log of x. Okay, and then just a bit on notation. The sine inverse, if you look at this in the textbook or online, you might see it be written as arc sine. Okay, so you can go back and forth between the two. Sine inverse or arc sine, they mean the same thing. So if you're watching some online video on it and they say arc sine, that's the same thing as sine inverse. Okay, so here we have a composition. The outside function is sine inverse. We know what to do with that. The inside function is the natural log. We know what to do with that. So y prime, the derivative of the outside function, that's going to be 1 over root 1 minus x squared. But in place of x, we're going to put the natural log of x. So that's 1 over the root 1 minus the natural log of x squared. Okay, so whatever the derivative of sine inverse is, we need to put the g function there, right? It was the f of g, so it's going to be f prime of g. So you need to put the natural log there. Okay, times. Then the derivative of the inside function, that's the derivative of the natural log. We did that yesterday, that's 1 over x. Okay, again, no simplification needed. You can just leave it as the product of each things. Okay, number 5. Okay, here we have y is equal to cos inverse of x squared. That was homework for you to do. Okay, so the outside function is cos inverse. We know how to differentiate that. The inside function is x squared. We know how to differentiate that. So y prime, that's going to be minus 1 over root 1 minus x squared squared. Again, if it was just cos inverse, it would be x squared. But since we've got that inside function, we need to put the inside function there. You can simplify that to x to the 4, but this shows how we're substituting. Okay, but in your notes, if you want to simplify, that's fine. Okay, times. And then the derivative of the inside function, that's the derivative of x squared, that's going to be 2x. Okay, please remember over here to substitute whatever the g is. So when you're doing the chain rule, it's f prime of g of x times g prime of x. Okay, it's very important that you put this inside part. So there, that's over there. Okay, in green. Okay, if it was just cos inverse, that would just be an x, but it's cos inverse of x squared, so we need to put the x squared inside. Okay, please don't forget that. Someone ask a question? Okay. Okay, number 6. So we have y is equal to x squared sine of x squared. Okay, now we've got two things going on. Firstly, it's a product of two things. We've got x squared as the first function, sine of x squared as the second function. So we're going to have to use the product rule. And secondly, it's sine of x squared. So we're going to have to use the chain rule. So product rule first, because it's a product of two things. Then when we're differentiating that second part, we need to remember to use the chain rule. So let's do it in pieces. So y prime. We differentiate the first one, leave the second. So it's going to be 2x sine x squared plus. Now we leave the first one and differentiate the second. Let's not do too much, so I'll leave it as x squared sine of x squared prime. And then I'll do that on the second line. If you can do everything on one line, that's perfectly fine. If you want to split up your work, that's fine as well. Okay, so y prime, that's going to be 2x sine of x squared plus the x squared from there. Okay, now we need to use the chain rule. Sine, that's the outside function. The derivative of sine is cos. So it's going to be cos of x squared. times chain rule, derivative of the inside function, that's the derivative of x squared, that's 2x. Okay, you can leave it like this, you can multiply it out, leaving it like this is perfectly fine. Okay, number 7, so we have y is equal to 1 plus x over 1 minus x. Okay, we now have a quotient of two things. Okay, we've got a top part and a bottom part. We're going to have to use the quotient rule. If you forget what that is, so that's going to be f prime g minus g prime f over g squared. Okay, so if you ever have to just write that down on the side in the test, that's fine, but that won't be provided for you. Okay, you need to remember that. Okay, y prime. So f prime, that's the derivative of the top part, that's just going to be a 1. Then g is 1 minus x, minus g prime is minus 1, f is 1 plus x, all over the bottom squared, so that's 1 minus x squared. Okay, again, you can simplify that. The ones, you can add those together. The x's over there, you can add them together. But this shows you the different parts. So the first bracket, that's going to be f prime and then g prime f. So you can see it like that. You can simplify that on your own. Okay, number 8. Okay, so here we have x squared plus sine inverse of y is equal to e to the xy. Okay, so again, we want to find y prime. Notice how we have y inside the sine inverse, and we also have it in the exponential. So it's not y equals something, y is quite mixed in with the equation. So we're going to have to use implicit differentiation. Okay, again, I'm just going to give you the question. I'm not going to tell you what to do. You just need to know if it looks like this, the y is mixed in, it's implicit. If it's y equals something, then it's explicit. Okay, so here d by dx of the one side and d by dx of the other side. Okay, so we're going to have to use the chain rule for the sine inverse, and we're going to have to use the chain rule and the product rule for that right-hand side. Okay, but we'll get to that. Okay, derivative of x squared, that's 2x. The derivative of sine inverse y, we need to use the chain rule because it's sine inverse of y of x. That's a composition. So it's going to be 1 over root 1 minus y squared times y prime. Okay, so I've used the chain rule there. Next, the derivative of the exponential is just the exponential, so that stays. Now the derivative of the exponent there. So we're trying to differentiate x times y. We need the product rule. So we differentiate x, that's going to give us 1 times y plus x times y prime. Okay, so I've used the product rule there. And again, the derivative of y, that's just y prime. Okay, so we're going to have to solve for y prime. Let's see where that is. There's a y prime over there, and there's a y prime over there. So we want all the y prime terms together so that we can then solve for it. Okay, so let's write this 2x plus y prime times 1 over root 1 minus y squared equals y times e to the xy plus y prime x e to the xy. So just expand it out a little bit so that I can get the y primes together. Okay, we've got y prime on the left-hand side, we've got 1 on the right-hand side. Let's take everything over to one side, and then the leftover 2x, we need to take that over to the other side. Okay, so we're going to have y prime, 1 over root 1 minus y squared, and then we took the other term over, so that's minus x e to the xy, equals y e to the xy, and then we took the 2x over to the other side. Okay, now again, we still want to solve for this y prime. over there. So we're going to have to divide by all that stuff in front. So that's y prime is equal to the right-hand side, that stays the same. Okay, divided by all that stuff in front. So that's the 1 over root 1 minus y squared minus x e to the xy. Okay, quite messy. I don't know if we can do any simplification here, but that's our answer. Okay, any questions on this? Okay, so it's the same steps that we did in the last lecture with implicit differentiation. D by dx on both sides. Collect your y terms, your y prime terms on the one side. You put everything else to the other side, and then solve for y prime. Okay, whatever is given to you, it's always those same steps. Okay, so that was number 8. Let's look at number 9. Okay, so here we have y is equal to x squared ln x. Okay, not so much going on here. We've got a product of two things, so x squared times the natural log, and remember that the natural log is one of those inverse functions. Okay, so we know how to differentiate that. So y prime, that's going to be the derivative of the first term times the second, so 2x natural log of x, plus the first term stays the same, derivative of the second, we get plus x. Okay, any questions on that? Anyone confused? You confused? Is your hand up or not? Hello? You? You good? Okay. Anyone else? Okay, let's move on. Number 10. So we have y is equal to the natural log of sine x. Okay, so now we have an inverse function, the natural log, and a composition because it's the natural log of sine of x. We've got a composition there. So y prime, that's going to be the derivative of the natural log, that's 1 over the stuff inside, so 1 over sine x, times the derivative of sine x, that's cos x, and we can write this as cotan x. Okay, so cos over sine, that's going to be cotan. Okay, 11. So we have y equals x ln x minus x. Okay, so for the first term, product rule, because we've got some function which is x times the natural log of x. So product rule on that, the minus x, nothing to worry about that, that's just minus 1. So y prime, we differentiate the first term, that's 1, leave the second term alone, natural log of x, plus, leave the first term alone, times the derivative of the natural log of x, that's 1, and then minus x, so that will be minus 1. And so we just get the natural log of x. Okay, 12. So we have y is equal to 4x squared plus 1 to the power 7. Okay, so again, we've got this composition. The outside function is something to the power 7. The inside function is 4x squared plus 1. So we differentiate the outside function first. So we take the 7 down using the power rule. The inside bit stays the same. So that becomes 7 times the inside stuff to the 6 times, and then the derivative of the inside part, that's going to be 8x. Okay, and then the derivative of 1, that's 0, so we can just leave that out. Okay, any issues so far? All good. Okay, 13. So here we have y is equal to the root of e to the x plus 1. Okay, so again, composition, outside function is the root of something, the inside function, that's e to the x plus 1. So we need to differentiate the outside function first. So that's going to be 1 over 2 roots e to the x plus 1 times, and then the derivative on the inside function, that's going to be e to the x plus 0. We can just write that as e to the x. Okay, so e to the x over 2 roots e to the x plus 1. Okay, any issues with this one? No issues. Okay, 14. Okay, so y is equal to 1 plus the natural log of x, all of that squared. Okay, so we've got a composition again. Outside function is something squared. Inside function is 1 plus the natural log of x. So y prime, the derivative of something squared, we take the 2 down, so that's going to be 2, 1 plus the natural log of x to the 1. If you want to write that down, that's fine. If you want to leave the 1, that's fine as well. Times, and then the derivative of the inside part, that's just 1 over x. Okay, please don't forget to differentiate the inside part. Any issues with this one? Okay, I hope there's still no issues when we do the next section. Okay, 15. So here we have y equals 1 over 1 plus x. Okay, you can either use the quotient rule, but remember the derivative of the top will just be 0. So whatever quotient rule you have there, f prime, that's just 0. Okay, or you could write this as 1 plus x to the minus 1. Okay, that's another way of doing that. Since all of that stuff is in the denominator, it has an exponent of minus 1. So y prime, that's going to be minus 1 plus x to the minus 2, or you can write that as minus 1 over 1 plus x squared. Okay, so 2 different ways of seeing it. You can either do the quotient rule where f prime is 0, or you can treat it as a composition with the power minus 1. Okay, you get the same answer in the end. Okay, 16. So here we have cos inverse of y plus sine inverse of y is equal to x squared. Okay, again, like we had for number 8, the y's are mixed in with the equation. So we know that we're going to have to use implicit differentiation. So we take d by dx on both sides. So that's cos inverse y plus sine inverse y. And on the other side, we get d by dx of x squared. Okay. The derivative of cos inverse y, that's going to be minus 1 over root 1 minus y squared times y prime. Okay. Plus, and then we have the derivative of sine inverse, that's going to be 1 over root 1 minus y squared y prime. And here we get 2x. Okay. Notice something interesting here. This minus 1 over root 1 minus y squared, and then plus 1 over root 1 minus y squared. Okay, what's going to happen with that? What happens to that side? Cancels. Okay, so on this side, what do we end up with? 0. Okay, on the other side, we have x. Now, what does this curve actually look like? Remember, we're trying to find the gradient. Okay, let's see what this curve looks like and then try and make sense of that answer. So all of you should be familiar with Desmos now, after all the homework you've been doing. Okay, so here, let that load. Okay, so we had cos inverse, or you can write it as arc cos of y plus arc sine of y equals x squared. Okay, so we end up with something like this. Okay, so that's what the curve looks like. It's actually two sets of curves. So on the one side, we'll cover this later when we do parametric equations, but here you can solve for y somehow. You don't have to worry about that. But you end up with two line solutions. So you end up with one solution over here, okay, on that side, and another one on that side. Can you find the gradient of this vertical line? Vertical line, does it have a gradient? No. So we see that y prime here doesn't make sense, right? Okay. If we change this up a bit, so I encourage you to mess around with this. So let's put a 2 there, maybe a 3 there. Okay, see, we end up with something different. So in this case, again, we get these two pieces. So we have the one piece on the one side, the other piece on the other side. And now you can find the gradient with that. Okay, so here, the original one, here and here. Since we have these vertical lines don't have gradients, you can't find y prime. Okay. So here, when you factor this out, you end up with y prime times 0 is equal to 2x. Okay, and in this case, there's no y prime solution. Okay, 17. So here we have 1 plus tan squared y plus x equals x plus xy. Okay, so just before I get the homework for this bit. Okay, so let's say we had cos inverse y plus sine inverse ky equals x squared. Okay, so like I put on Desmos, you change the factors there. For which values of k does this have a solution? Is there a solution for y prime? Okay, so if k is 1, then you just get the vertical lines. There's no y prime solution. But like I showed on Desmos, if you change it a little bit, you do end up with a solution. Okay, so which values of k is there a solution for y prime? Okay, so let's go to 17 here. Okay, again, y is mixed up in with the equation. We've got the tan squared y, and then on the other side we have x times y. So this is another implicit equation. So d by dx on the one side and d by dx on the other side. Okay, so the derivative of tan squared, we need to think of that as the derivative of tan y squared. Okay, just because it's written as tan squared like that doesn't mean it's not a composition. It's tan of y and then squared. Okay, so you need to think of it like that. Okay, and then on the other side, that's going to be 1 plus y plus xy prime. Okay, so the derivative of tan squared, since we wrote it like this, it's a bit more clear of the composition. So we have tan on the inside, squared. So that's going to be 2 tan y to the 1, if you want to write it like that, times the derivative of tan, which is sec squared. Okay, and then y prime. And that's equal to 1 plus y plus xy prime. Okay, so we're interested in this y prime there and that y prime there. So we take all of that to one side, everything else to the other side. So we're going to have 2 tan y sec squared y prime minus xy prime is equal to 1 plus y. Okay, then we can factor out the y prime, divide by the rest, so we get y prime equals 1 plus y all over 2 tan y sec squared y minus x. Okay, then we end up with that. Okay, and then if I gave you some points along the curve, you could then find the tangent line and the normal line. Okay, but here we're just interested in y prime. Okay, 18. Okay, so here we have y is equal to x squared over the natural log of x. Okay, again, we've got the quotients. So some f at the top, some g at the bottom, and we want y prime. Okay, so again, if you forget what the formula is, f prime g minus g prime f over g squared. Okay, so f prime, that's the derivative of the top one, so that's just going to be 2x. G, that's the natural log of x. Minus g prime f, so that's going to be x. All over g squared, so that's the natural log of x squared. Okay, you could factor the x out at the top, but that's not needed. You can leave it like this. Okay, any issues with this one? Okay, 19. Okay, so we have y is equal to x sine x all over cos x. Okay, so just looking at this quickly, you might think you have to do the quotient rule because we have something at the top, something at the bottom. But remember, sine over cos, that's just tan. So we can write this as x tan x. Now, instead of the quotient rule with the top being a product, we now just have the product rule. Okay, so if you can simplify the expression before taking the derivative, that helps quite a bit. Okay, so y prime, derivative of the first term, that's going to be 1. We leave the second term alone, so that's tan x. Plus, we leave the first term alone, derivative of the second, that's going to be sec squared x. Okay, any issues with this one? Okay, so everyone's good so far. Okay, 20. So here we have y is equal to root x cos inverse x. Okay, got a product of two things. Root x, that's the first function. Cos inverse, that's the second. Okay, we know how to deal with cos inverse. So y prime, that's going to be derivative of the first one times the second. So that's 1 over 2 root x cos inverse x plus root x times, and then the derivative of the second, we know that's minus 1 over root 1 minus x squared. Okay, again, you could simplify this, but that's not needed. If the question just says find the derivative, you can leave it like that. If there's follow-up questions, maybe it would be nice to simplify. Okay, but that's up to you. Okay, 21. So we have y is equal to sine x cos x. Okay, now there's two ways of doing this. You can either treat it as the product rule, so we've got the product of two things, or you could write this as 1/2 sine 2x, and then just differentiate that. Okay, so that's up to you how you want to do it. Okay, so here y prime, that's going to be cos 2x. Okay, so you can either treat it like a product, and then you'll end up with a product of a sum of two terms. They'll add up to cos 2x. So either way, if you treat it like a product, or you use your double angle formula, you get the same answer in the end. Okay, 22 is something similar. We have y is equal to sine hyperbolic x cos hyperbolic x. Okay, again, product of two things. Let's use the product rule for this one. So we have y prime is equal to the derivative of the first one, leave the second alone. So we're going to end up with cos hyperbolic x squared plus, then we leave the first one, take the derivative of the second, and then we end up with sine hyperbolic x squared. Okay, now there's no identity for adding the squares. Remember, it's when we subtract them. So cos hyperbolic squared minus sine hyperbolic squared, that's going to be 1. Okay, if we add them, we don't know what we're going to get. It's not an identity. Okay, 23. Okay, so we have y is equal to the natural log of e to the x plus 1. Okay, again, we've got a composition, the natural log on the outside, e to the x plus 1 on the inside. So we're going to have 1 over the stuff inside times the derivative of the stuff inside. So y prime, that will be e to the x over e to the x plus 1. Okay, so 1 over the stuff inside, and then times the derivative of the stuff inside. Okay, 24. We have y is equal to the root of 2 plus root x. Okay, we've got a composition of roots here. We know how to deal with roots, so that's fine. Roots on the outside, and then 2 plus root x on the inside. So let's look at the outside bit first. So y prime, that's going to be 1 over 2 root 2 plus root x times, and then the derivative of the inside part, that's going to be 1 over 2 root x. Okay, so if you want to combine that, that's fine. So we end up with 1 over 4 root x root 2 plus root x. Okay, you don't need to combine it. You can leave it like we had in the first line. Okay, any issues with this one? Okay, so we took the derivative of the outside to get this. So that's 2 plus root x to the half. Okay, so we took the half down, so that makes the 2 at the bottom. Minus 1 from the exponent makes it minus a half, but minus a half is just a root at the bottom. Okay, good? Okay, do you need me to show the working? Okay, so we have 2 plus root x to the half. Oh, sorry. Okay, so we'll go through it step by step. So we ignore the inside part. Okay, that's just the inside part. We're not worried about that. We have the power 1/2. Okay, so we're going to use the power rule. So we take the exponent down. So that will be 1/2, 2 plus root x to the half minus 1. Okay, times, and then the derivative of the inside part. But the inside part is just root x, so we do the same thing. So it's going to be 1/2 x to the half minus 1. Okay, so the half and the half, that makes a quarter. 2 plus root x, a half minus 1, that's minus a half. And then x, again, a half minus 1, that's minus a half. But if the exponent is negative, we just put it down to the bottom. So that's going to be 1/4, 1 over the root 2 plus root x. And again, the exponent is negative, so we put it down to the bottom. That's 1 over root x. Okay, good. Okay. 25. Okay, so here we have x cubed minus y cubed is equal to y. Okay, again, the y is mixed in with the equation, so we're going to have to use implicit differentiation. So d by dx on the one side and d by dx on the other side. Okay, the derivative of x cubed, that's just 3x squared. Derivative of y cubed, that's y of x cubed. Okay, so chain rule there. That's going to be 3y squared, y prime. Okay, and then d by dx of y, that's just y prime. Okay, so we've got a y prime over here and over here. We can take the y primes to one side. So we're going to have 3x squared, that's y prime, plus 3y squared, y prime. Okay, now we can just factor out the y prime. So y prime, that's going to be 3x squared over 1 plus 3y squared. Okay, any issues with this one? Everyone's fine with that. Okay. 26. Okay, so we have y is equal to the natural log of the natural log of x. Okay, so we've got this double composition here. So natural log on the outside and natural log on the inside. So y prime, that's going to be 1 over the natural log of x for that first bit. Okay, times 1 over x for the derivative of the inside part. Okay, so 1 over natural log of x for the outside function, 1 over x for the inside function. Okay, the next one's a bit interesting. So we have y equals x to the x. Okay, so here we can't use any power rule because the exponent is x. Okay, we can only use the power rule if it's something like x squared or x cubed or x to the half. Here we can't do that. So what we're going to do is rewrite this as e to the natural log of x to the x. So e to the natural log of x, they cancel and we're left with x. So in the end, this is just x to the x again. Okay, but now we can write this as e to the x natural log of x. And we can differentiate that. That's quite easy to do. So y prime, that's going to be e to the x natural log of x. That stays because of the exponential property. Okay, now we need to differentiate the inside part. So the derivative of x, that's just 1. So we have the natural log of x plus 1. Okay, and if you want this e to the x natural log of x, we can put x to the x back there. Okay, so little pre-step there. We just wrote x as e to the natural log of x because we know they cancel. And we'll end up just with x back again. Okay, any issues with this? Yeah. Yeah, so e and the natural log, those are inverses. So they always cancel. So here, there's the two ways of writing it. So e to the natural log of x, that's just x. And the natural log of e to the x, that's also x. It's like the f of f inverse and f inverse of f. You can do it both ways. Okay, so they're just inverses. It's like writing f of f inverse and f inverse of f. Okay, they just give you x. Okay, any other issues on this one? All good. Okay, 28. Okay, so here we have y is equal to the natural log of cos squared x. Okay, so here we've got three compositions, natural log on the outside, something squared on the inside, and then in that we then have cos. So here y prime, that's going to be 1 over cos squared for the outside function times 2 cos x minus sine x. Okay, so this is going to be minus 2 sine x over cos x. We can cancel the cos there, so that's minus 2 tan x. Okay, so again, you just need to take care of your composition. So if it's cos squared, remember cos squared is also a composition. So cos squared x, that's cos x squared. Okay, so don't treat cos squared as a function just by itself. It is also a composition. Okay, then the remaining ones I'm going to leave for homework. Okay, and then I just have a quick announcement about the current class mark. Okay, so we have y is equal to e to the minus x sine x. Y is equal to 1 over root 3x plus 5. And y is equal, natural log of y plus e to the y is equal to x squared y. Okay, remember that last one, you're going to have to use your implicit differentiation.